The Dragon curve is a fractal discovered by NASA physicist John Hayway in 1966. It got its first big boost in popularity from the novel Jurassic Park, where a pontificating mathematician uses it as a metaphor for dinosaurs running out of control. And today, I'm going to show you how to build one in one Excel formula. Welcome to Excelopithecus. To start generating your dragon curve, you're going to need a turtle. A turtle is a list of instructions for a computer to move and draw things on a grid. The dragon curve has a relatively simple turtle with only two instructions. R means turn right and move. L means turn left and move. The turtle starts as a simple R, and with each iteration, it gets longer and longer. The rules for how to increase the length of the turtle are also fairly simple. If we start with the letter R, we put the initial turtle to the left of here, we add an extra R, and at the end, we add the turtle reversed with the R's converted to L's and the L's converted to R's. So R becomes RRL. If we do the second iteration, starting with RRL, we put RRL at the beginning, plus R, plus RLL. That's because RRL reversed is LRR, and the letters switched around give us RLL. So RRL becomes RRL, RRLL. Okay. Our next problem is how to translate the turtle into movement. The simplest way of moving on a grid is what I'd like to call Game Boy movement. Here, up is x plus 0, y plus 1. Down is x plus 0, y minus 1. Left is x minus 1. Y stays the same. And right is x plus 1. And y stays the same. But the problem with Game Boy movement is it doesn't really handle rotations very well. You don't know, for instance, how to program it so if you're facing right to go down if you want to turn right. A way to handle that is to use complex numbers. Now, I'm not going to offer a complete course in complex numbers. We're just going to go through the basics of how to use them to rotate, because Excel is fortunate enough to be one of the programming languages to belong to the complex number club. So, complex numbers store both the vertical and the horizontal position as a single value. If you raise the imaginary number I to the power of 1, it means up. If you raise it to the power of 2, it means left. If you raise it to the power of 3, it means down. And if you raise it to the power of 4, it means right. Each time you raise it by a power, it makes a quarter turn, and that's a counterclockwise quarter turn. So in Excel, these powers can be represented with the IMPOWER function. And to rotate, you simply need to add 3 to the current power of I to go right, and add 1 to the current power of I to go left. Here's a worked example. We start with a turtle going RRL, RRL, etc., etc., and we convert it into powers with the switch function. So R becomes 3 and L becomes 1. We then make a running total of those powers to get a moving running total that shows what the current power is, and convert these into complex numbers. To do the running total, we have to use the scan function, and you can use 1 as the initial value, feed it the powers, and put sum at the end. If you have a slightly older version of Excel, you have to take a slightly more roundabout approach, which instead of using sum at the end, you have to have lambda, open bracket, A, B, or whatever values you want to give to these numbers, and A plus B, and that'll do the same thing. And at the end, we use IMPOWER to convert them into complex numbers. Finally, there's the task of converting them back into real numbers. The IMREAL function extracts the horizontal axis as a regular number from a complex number. The imaginary function extracts the vertical axis position, and we would use the scan function again to make running totals to get a moving position. I now have a blank spreadsheet open so we can start building our turtle. We're going to build it as an array because it'll save us a lot of trouble later than having to use it as a block of letters and cut them apart. The core functions we'll be using here are VSTACK and switch. VSTACK is a relatively recent function that stacks data vertically. So, clicking on cell B2 and then adding an R and clicking on cell B2 again gives us RRR. But we want an L at the end, so we're going to use the switch function to convert it. The switch function takes an expression as the initial value, and then, depending on the value of the expression, gives different results. So if the value is R, we want it to give back an L, and if the value is L, we want it to give back an R. And that's it. We have our first iteration. Unfortunately, we still have a component missing, because if our initial turtle for later iterations is going to have more than one cell value, we're going to need to sort them for the final part of the turtle. The way we can do this is with sequence and sort by to turn them backwards. So, sequence, rows, and the array, putting a hashtag at the end after the starting cell captures the whole array, will get us a set of numbers equivalent to the number of rows, and the sort by function takes the array, what to sort it by, and the order. In this case, the array is our turtle. The numbers we sort them by are these, and we put a -1 to sort them backwards. LRR. Let's rebuild this so we can get our next iteration. We'll put it right here, and for our starting cell, we shall put this here, and then create the sort function. Sort by D2 hashtag, by sequence rows, D2 hashtag, and -1. This ought to give us our next iteration. RRL, RRLL. That's working perfectly. And if we drag, we can keep repeating it. But I'm not a fan of dragging and autofilling. So let's make this dynamic. We can do this with one of Excel's two recursive functions, reduce, which it conveniently stole from JavaScript. The reduce function works very similarly to scan, which you may have seen in my previous video on Mandelbrot sets. It starts with an initial value, which is going to be R, and then we're going to use an iteration count using the sequence function. It's going to run along this function simply as a timer without actually using the values. We can give it 4 iterations to begin with. Then we have to put in the transformation in a LAMBDA function. LAMBDA, for those of you who haven't used it before, is an Excel function that defines functions to reuse. In other words, transformations that turn inputs into outputs. We can name the two inputs A and B. We won't be using the B inside of the function because it simply stands for the timer. But we can start renaming everything A and getting rid of our cell reference. Then we simply have to close the brackets, and we will have a reduce function that returns the first 4 iterations of the dragon curve turtle. Voila! Finally, because we're going to do some more work with this, let's rename it turtle inside of a let function. The let function takes the name, then the thing the name belongs to, and then in the final compartment of it, after the last comma, it returns whatever you want it to return. So if you want it to return turtle, just type it here, and that's it. If you've made it this far, congratulations. You're over the hump. The tricky part is done. We now have our turtle defined inside of a let function, and we're going to start generating the coordinates. First step is to generate the powers. We can do this with another switch function. So put turtle as the expression, and then value 1r, we want to go 3, and L 1. And let's see what we get. 3, 3, 1, 3, 3, 1, 1, 3, 3, 3, etc. Next step for the powers is to turn them into a running total with scan. Our initial value will be 1. This is going to be our array, everything in that switch function, and the function we'll use for the running total is simply sum. We've summed up our powers into a running power. Next, we're going to raise the imaginary number to these powers. We will create a new variable called impowers, and impower as our function, I in double quotes, and powers. Impowers. We now have a whole bunch of our complex numbers. So, next step is to extract the real and imaginary components and do a further running total to get our moving position. So x shall be scan, initial value 0, IMREAL impowers, and sum, and we're going to want to round these because Excel's 15 digits of precision means that it sometimes won't give you perfectly round numbers when it's raising imaginary numbers to different powers. So round, and we'll round it to 0. Voila. And we can see our x's. Then we'll do the same thing for the y's, which we can just copy and paste the x and do a fairly similar transformation to it. And y, in this case, the only difference is instead of IMREAL, we will use imaginary. And that should be it. HSTACK, which stacks things horizontally, x, y. To see the dragon curve in action, we can now insert a chart over our HSTACK. Now, the only chart we can do this with is the scatter plot. And Excel scatter plot does not have many advantages over Power BI, but it does have one. It can draw a line between the dots. We're going to use this straight line, and we can see the first makings of our dragon curve. To keep increasing it in size, we simply have to increase the number of iterations in this sequence function. And you can see it growing here. But we want to make this a bit more dynamic, so we can turn this into a custom function. The only real input we're going to be using is the number of iterations, because everything else is worked out. So we can make this into a lambda, iterations, and replace this number with the iterations input. As always, when we test our lambda, we close the last bracket, and then we can create a little bubble here where we put in our input, and this will test it inside the worksheet before we embed it in Name Manager. Let's try it with iterations 10. And you can see a beautiful, gorgeous dragon curve developing. Let's put this into Name Manager now. Do not put the actual input into there, just everything after the last closed bracket of the lambda. Open Formulas and Name Manager. New. Put this here and call this Dragon Curve. OK. And close it. In my last video, I showed you how to use a spin button, and we're going to repeat that trick here. Let's just clear all of this junk and add it from Insert Form Controls and place it here and set it to this cell D2. And we'll make the minimum value 1. And next, we will simply grab our dragon curve and set the iterations here. Let's insert another of our scatter plots and go for something a little bit groovier with the rounded one. And we can see our dragon curve growing. Join me next time for more adventures in Excel programming at Excelopithecus.